Good morning everyone. I'm Sushmitha Priyadarshini. I'm talking about role of technology in hearing, and this is part 1, talking about hearing aids basically, and in next part I'll be talking about cochlear implants. So what is hearing aid? Hearing aids are sound amplifying devices, helps in treating people who have a hearing impairment that amplifies and changes sound to allow for improved communication. So this is basically used by hearing impaired patients, so that the hearing aid picks up the sounds and it amplifies it. It enhances the speech sounds and sends to the ear canal. So this is how it improves the communication better in their lifestyle. So the classification of hearing aids. Under the classification of hearing aids, we'll talk about types of hearing aids, where we have three system of hearing aids: receiver in the canal, behind the ear, and custom aids such as in the ear, completely in the canal, invisible in the canal. Behind the ear, this is the components which are built into housing, which is worn behind the ear. Sound is carried via soft plastic tubing to the ear canal. That means like we place the tube inside the ear, and the behind the ear component, the body of the hearing aid will be sit behind the ear, uh, such as ear hooks, battery compartment, volume control, mic, everything will be sitting in behind the ear. And under behind the ear, we have two types of hearing aids: traditional behind the ear and slim BT hearing aids. Traditional BT hearing aids will be having a ear mold, thicker tubing is used for more stability and power, and slim tubing BT is known for mini BT and open BT or open air ear fit hearing aid. So this is not a big thick tube. This is very slim. It looks like a receiver in the canal thing, but it won't be having a receiver outside as a part. So as I already told, traditional BT is having ear mold and thicker tubing, which is used for more stability and power, which handles extra sound pressure without distorting. And this is used by profound hearing loss patients, and also it works for mild through severe hearing loss also, based on their convenience. Slim BT, it is more of natural sound for high frequency loss, and it can be used by mild through moderate hearing loss patients. So you can see how slim BT looks like. So this tube is not thicker compared to the traditional BT, and this doesn't have a receiver, but it has a tip which is very slim. So if you look into the advantages and disadvantages, so BT can we use larger batteries, so that in BT basically larger batteries to smaller batteries also, where the larger batteries will come for longer period of durability, and this will be suitable for all kind of patients, all ages of the patients, like from children to the adults, and it helps in dexterity, where the old patients cannot hold the hearing aid properly and operate it. So behind the ear is really helpful for them to handle it very good compared to the other hearing aids. And disadvantages are like if it doesn't fit properly, or if it is damaged, the mold is damaged, the feedback could occur. The squealing sounds might be heard by the patient and even by the next neighbor people. And instruments are larger, which is not cosmetically appealed, so it will be visible compared to the other hearing aids. Next, we are talking about receiver in the canal. The receiver is no longer within the behind the ear unit, so it comes out of the body and it sits inside the ear canal. So and sits inside the ear canal. It is a thin tube which comes outside the body of the hearing aid, uh, and it is particularly small and light and inconspicuous. So the advantages are like it's smaller and lighter, and sound output is clearer and easy to this is disadvantages we can see, like is it's easy to lose as it is very small, and receiver can get damaged easily because it's very, the wire is very delicate, and it is more expensive to uh, compared to the behind the ear hearing aid. So next is custom hearing aids. Under custom hearing aids, there are in the ear, in the canal, completely in the canal, invisible in the canal hearing aids. In the ear hearing aid, it is the case houses all the miniatured hearing aid parts inside the ear canal itself, where it is available with programmable, digital and conventional technology. It can be used for wide range of hearing losses from um, even mild to moderately severe hearing loss, and it can be used for they are also much easier to handle, but it will be difficult for older patients and even younger patients. So this type of hearing aids fills the outer ear, and the hearing aid case is custom made of a hard plastic material. So easier to handle means like compared to the other custom made hearing aids, like completely in the canal and invisible in the canal, this is better to um, much easier to handle. So the advantages and disadvantages of this hearing aid is advantages, I can say it's wide range of hearing loss. We can use it for wide range of hearing loss patients, and it's larger sound amplifier, and more, it has more features, and it is also easier to handle and adjust, but not for children because their ear canal will be growing continuously, and it is easily visible compared to completely in the canal, and feedback might occur because means if it doesn't fit properly inside the ear canal, we can hear the feedback, and size of the battery door and volume control might be difficult to adjust for older patients, as I already told, and damaged by earwax and drainage can occur. In the canal hearing aid, it fit in the ear canal. They're only slightly larger than the completely in the canal and hearing aid, but smaller compared to in the ear hearing aid. And the ITC style is available in the programmable, digital, and conventional hearing aids. So the advantages of ITC hearing aids are it is cosmetically appealing because of the small size, and it offers natural sound reception due to the placement of the microphone is in the ear canal, which is near to the ear canal eardrum. And disadvantages are like volume control is cannot be operated very easily, and because it's very small and difficult to adjust. Completely in the canal, so this is the smallest size of hearing aids, practically invisible to observer, means it is not so small compared to invisible in the canal, but it's smaller compared to other hearing aids like ITC and ITE. And CIC hearing aids fit deep inside the ear canal, and most closely resemble the natural hearing process. And CIC instruments can have conventional, programmable, analog or digital technology housed within their tiny casing. Advantages are it's very small, and it is nearly invisible, and it is cosmetically appealing because of the small size, and it sits very closer to the eardrum, so it boosts the natural sound, naturalness and loudness. And the microphone of a CIC instrument sits in your ear canal, stimulating natural sound reception, as already discussed. So disadvantages are, it is more expensive than the conventional in the ear hearing aids, and not for the person who are suffering from severe to profound hearing loss. It's only for mild, basically from mild to moderately severe hearing loss. And it's a higher repair rate compared to other hearing aid sizes, and it has no volume controls, and it doesn't recommend it to the children. Invisibly in the canal, it is very tiny hearing aid, you can see in the picture. So it sits very close to the eardrum, and it goes deeper in the ear canal. So it's basically someone should mm, be able to tell only when only if you tell them that you are wearing hearing aid. So nowadays, we are getting more of rechargeable hearing aids, and it has smart adopting technology to different listening situations without the intervention of the user. So next we are talking about hearing aid systems, like FM systems, induction loop system, um, etc. So first I'll be talking about induction loop system, where induction loops take advantage of connection between electricity and magnetism by converting audio signal to electrical signal, and that flows through a loop of wire, where loop of wire uh, will be around the neck of the receiver, and all, or the chair of the receiver, and it is connected to the hearing aid and also to the speaker. Hence into a magnetic field that travels across space at the speed of light. This field is sensed by a coil of wire and induces an electric voltage in the coil. This voltage is then amplified and converted by receiver back into sounds. So this loop that emits the magnetic field can be as large as a length of wire around the perimeter of an auditorium, or as small as a device that can fit in the behind the ear alongside the usual hearing aid. In between, there are loops that surround an individual listener on the floor or attached to a favorite chair, and loops that are worn around the neck, as I already said, and neck of the listener. And the coil that picks up the magnetic signal is invariably mounted inside the listener's hearing aid. So this loop will be connected to the hearing aid, and the sound will be converted audio signal to the electrical signal through all this process. So next is radio frequency transmission. This is a kind of a portable transmission system. So to get a signal from a talker to a listener without correcting the signal by noise or reverberation. So nowadays we call this is FM system. This is also called as FM system, and nowadays it is we are using multi mic as such. So the audio electrical signal is not directly converted to another form of energy, but here it is instead modifies or modulates the characteristics of an electromagnetic wave. This electromagnetic wave is called the carrier, and in the absence of an audio signal, the carrier is a sinusoidal wave. It can convey information only when the audio signal alters some aspects of the carrier. So the basically this transmitter will be used by the talker. He wears it, and the transmitter may contain a microphone, in which microphone uh, in which case the transmitter is worn around the neck. Alternatively, a microphone is attached to the transmitters by a cable, in which case the transmitter is clipped to a belt or worn in a pocket, and the microphone is also clipped to the lapel or worn on the head. So the connecting cable may also serve as an aerial for the transmitter. The receiver is worn by the hearing impaired person. So the listener will be keeping this thing receiver, and the transmitter mic will be used by the speaker. So when speaker speaks, it picks up the sound and sends the signal directly to the receiver through receiver. Hearing impaired patient. So it can connect electrically to the hearing aid by the cable. Infrared transmission. Here, infrared radiation is the same type of electromagnetic energy as radio waves, except that it occurs at a much higher frequency, approximately 10 to the power of 14 hertz. And transmission of audio signals via infrared electromagnetic waves also requires that the carrier by modulating by the audio wave. The infrared wave is pulsed on and off with the audio signal, directly or indirectly controlling the timing of the pulses. The infrared receiver first directs the pulsing infrared carrier and then demodulates the pulses to recover the audio signals. The classroom sound field amplification. Here it gets sound to the listener using acoustic waves propagated across the room, and as this is affected by the distance from the talker and the background noises, both problems can be minimized by amplifying the wanted sound and by positioning loudspeaker near to the listener. And the most common application is a classroom, and the most basic system thus consists of microphone, an amplifier, and one or more loudspeakers. Assistive listening devices. These are the devices that help hearing impaired patients to detect sounds through or understand speech through various modes, and it can be worn by head or body, or it can be external part as well, and are referred to as assistive listening devices. They can be categorized into those that improve intelligibility and those that detect the environmental events, and ALDs can be used in conjunction with hearing aids or instead of hearing aid. So it is an extra accessories like as I said, it's a multi-mic or TV unit where the TV sounds can be heard directly and to the hearing aids, and it can be alert system where if there is smoke in the house, or some danger is there like fire, or some thefts, robberies are happening, so it gives alerts to the patient through various modes. It can be various modes like vibration, so the patients will be holding the vibratory equipment in their hands, so if someone knocks the door, also it can give a signal to them, and there will be a light where it lights up when someone is knocking the door or telephone ringing, anything else, etc. ALD intelligibility. Intelligibility is improved by locating microphone closer to the source than is usually possible for the user to be, or by directly connecting a source device such as TV to a transmitter. And ALDs that improve speech intelligibility can be further categorized according to their purpose. So one-to-one communication, group listening system, television devices, telephone devices. So as I already discussed, so there is a extra accessories, phone clips, multi mic, and TV units, where multi-mics can help beyond 15 feet, so like in a group conversation, in a um, um, conferences, a hall, meeting hall, so mic can be kept in middle of the table, and it picks the sound and directly transmits to the hearing aids. And the television devices is the device that connects to the TV, and this TV inputs will be directly transmitted to the hearing aid, and the clarity will be very good. And telephone devices is like it helps in direct streaming the phone calls which they get in phones. So, and ALDs also have like a alert system for environmental events, like alerting. ALD comprises sensor of some type linked to an output that can be easily detected by the hearing aid patient, like flashing light, vibrator, or intense low frequency sound, as I already discussed in the last slide. And the most common sensors, detectors, or triggers are like telephone ring sensor, baby cry sensor, smoke detector, alarm clock, and doorbell sensor. So here are the pictures you can see. There is a vibrator, smoke alarm, and the doorbell alarm system, danger alarm system. And here we discuss about new and advanced hearing aid technologies that are adopted to the hearing aids nowadays. So before there were only analog and digital system, where analog is like just increases the sound and decreases the sound without related to any frequencies as such specifically. And uh, digital hearing aids are like we can alter the sounds according to their frequencies and all, but still in digital hearing aids we have more advanced technology features adopting into nowadays. So as the level of technology increases, digital hearing aids become more automatic and have more features to help you communicate in difficult listening situations. So the following features are more likely to be offered in advanced hearing aids. One is top of the line sound processing and frequency response, Bluetooth compatibility, artificial intelligence, apps, rechargeable batteries, tinnitus masking features, and waterproof design, and two-way audio as well. Top of the line sound processing and frequency response. So here we can find like nowadays the hearing aids will be having bands and channels where all hearing aids process sound. So that means like when sound arrives into the hearing aid, it will be sectioned into different bands of the sounds, which we call it as channels, and it will be digitized for each band before it amplifies. And the better the hearing aid, it is more flexible, and it has to band sounds that are amplified for your unique hearing loss prescription. So so for example, you have a high frequency hearing loss, it is better made hearing aid can amplify only the high frequency sounds within that band. So whereas a lower end model might amplify mid and high frequency sounds, this customization of the hearing aid is called its frequency response. So that means like so if you have a high frequency loss, high frequency sounds will be enhanced rather than the mid and low frequency. But whereas lower end hearing aids, even it's not specified to high frequency, it also includes mid frequency to you can to alter it. Bluetooth compatibility is nothing but like as we use AirPods and all, it has hearing aids also has Bluetooth facilities where it directly connects to the hearing aid to the phone. So whenever the phone call comes, you can directly speak by selecting Bluetooth instead of holding the phone on your ear. And it is a wireless feature that enables hearing aids to connect mobile phones and other devices that use Bluetooth, often through intermediary devices. That means sometimes we use phone clips as such. Some hearing aids, some advanced hearing aids has won't you doesn't use the any of the extra accessories, it directly streams to the phone. And Bluetooth technology has the ability to improve signal to noise ratio and eliminate feedback from the microphone, because it directly streams, it doesn't have to affect the signal SNR ratios and feedbacks and all. It eliminates all such factors, and the signal bypasses the microphone and directly enters the hearing aids processor. It's already okay. A Bluetooth connection is also less likely to experience interference, which can occur with the FM system. So artificial intelligence. Nowadays recent hearing aids are adapted to the artificial intelligence technologies, and artificial intelligence technologies. This allows them to access a deep neural network to process sound, and by logging into volume control and program preferences and all, it automatically adjusts according to the environment, and it learns about the different environmental sounds and noise, quiet, everything, and it adjusts automatically by itself. And essentially, deep neural network allows hearing aids to begin to mimic how exactly your brain would hear sound if your hearing wasn't impaired. So it gives you the naturalness of the sound, um, uh, basically. Next is apps. So nowadays, most of the hearing aids will be having will come with this apps and all. So where the user can adjust the volume controls and contact the hearing care provider and monitor the battery lives, and even their extra accessories can be altered. And even it will be having a Google locations, where if their hearing aids are missing, so they'll be knowing where they lost it. So all these technologies are adopted into the hearing aids for premium hearing aids, which is higher end hearing aids. And even it will be having motion sensor also, like if the patient is where they are moving, that also can be read through the hearing aids and the app as well. So it will give the alert to their guardians as well, like if they fall down, or if it is missing, etc. So most importantly, some of them work like assistive listening devices by routing phone calls or other sources of sounds directly to users hearing aid. And nowadays, the technology has improved, where speech can be converted into text, and also it translates the different languages into their language, which will be seen in apps. In most of them find in Apple Watch, iPhone, basically Apple Watch with hearing aids, iPhone with hearing aids, etc. Rechargeable batteries. Increasingly, hearing aids have rechargeable batteries, allowing a person to stop swapping out tiny button batteries every few days or weeks. So it's anticipated that these will be widely available with most hearing aid models in the next few years. So nowadays, rechargeable hearing aids are there, so no need to change the batteries as such. Like so, it will come like a portable charger, where you have to charge the portable charger for one whole night, and it can be used as a AirPods for the whole week, where you have to keep the hearing aids inside the portable charger, and it will be charged automatically. Tinnitus masking feature. The most sophisticated hearing aids come with tinnitus masking features. These hearing aids can be programmed to emit sounds that mask the tinnitus or ringing in your ears. So, but for many people with tinnitus, it simply amplifies the sounds they are missing. With hearing aids, can help minimize tinnitus, which often develops when a person experiences age-related hearing loss. Waterproof design. Most hearing aids today are water resistant and not waterproof. So now Now, recently, a hearing aid company have introduced waterproof hearing aid, uh, so that they say can be submerged in up to 2 feet of water. Two-way audio. Several manufacturers are now making hearing aids with two-way streaming audio in the microphone, which makes hands-free calling easier. So when a call comes into your smartphone, you can hear and speak via your hearing aids microphone. Basic hearing aid technology. So although still programmable by computer, basic hearing aids have limited adjustments available for fine-tuning to fit unusual patterns of hearing loss. So they are also less customizable and automated than hearing aids with advanced technology. Basic digital hearing aids also generally require you to make some manual adjustments in certain listening situations, such as volume control up and down, and push button on the aids to reduce noise coming from behind. And the following are examples of features that are usually included in basic hearing aid technology. So there is wireless hearing aids, where wireless technology allows two hearing aids to operate together as one complete system instead of acting as two independent devices. So you can alter one hearing aid, and it's automatically both the hearing aids will communicate and act accordingly. So this technology mimics the brain's ability to process information coming from both ears and helps reduce manual adjustments. So one hearing aid can be we can adjust, and it communicates with other hearing aid, and it automatically reduces or increases the volume control, or so it basically mimics the brain. And for example, if the sound input to both hearing aids is shared, and decisions about the digital sound processing are based on the combined information. This is known as a binaural processing. So, for example, if one hearing aid is being triggered for directional mode, both hearing aids would likely switch into the mode that at the same time. So, the data transfer rates for wireless hearing aids are measured in nanoseconds, which is much faster than human brain can detect. For the wearer, the adjustments are perceived in real time, and sound processing is therefore synchronized between the two hearing aids, thus improving sound quality for the wearer. So the wireless hearing aids are can be communicated with external devices via Bluetooth telecoils that work with hearing loops and frequency modulation systems. In essence, the wireless technology improves hearing aids in two ways: by improving how the hearing aid connect with each other, um, delivers sound as a collaborative pair instead of separately, and by making it easier to connect with the world around you as well as your favorite devices like smartphones. Digital noise reduction. Here it analyzes the signal to determine if it contains unwanted noise. So if this noise is detected, the system reduces the level of noise, and this features makes the background or environmental noise less annoying, and it increases the listening comfortness. And digital noise reduction is also shown to be effective and preferred by hearing aid wearers. Impulse noise reduction. Similar in purpose to digital noise reduction, impulse noise reduction improves listening comfort. This system detects the transient loud noises such as car keys rattling, typing keyboard, or dishes rattling, and softens them instantly. So like sudden, basically it's a sudden sounds, sudden loud sounds. So that is called as impulse noise, and it detects and reduces by or reduces the loudness automatically. Wind noise reduction. Although fairly specific in its application, wind noise reduction can make a world of difference for those who spend time enjoying outdoor hobbies like golfers and boaters. So like it basically reduces the wind noise like while traveling outside, so the air will be entering to the hearing aid, and that noise cause discomfortness to hear to the people. So this will be reduced by the hearing aid automatically. So wind noise reduction detects the impact of the wind blowing across the hearing aid microphones and avoids or reduces the amplification of it. So feedback management systems, here the feedback management systems combat the inevitable feedback, that is whistling, that occurs in a hearing aid. So if the hearing aid is not fitting properly, then usually patient starts getting feedback sounds, squealing sounds outside of the hearing aid. So these feedback loops create an annoying whistling sound. So as that affects the comfortness of the hearing. So the feedback management algorithms can be implemented differently for basic hearing aids or advanced hearing aids. Basic feedback management systems may reduce the overall amplification to remove the to remove the whistling. And advanced feedback management systems reduce or eliminate whistling without affecting the overall amplification of the hearing aid. So the data logging, it is one of the important feature that stores the data, like how long whether the patient have used the hearing aids and in what situations they have used. So, like whether in quiet situations or at the outside with noise, how long they have used, everything will be recorded here. So it is the feature that stores data about the listening environments in which you weigh the hearing aids and the patient preferences for programs, volume levels, and other features. So the information can be accessed by the hearing health care professions when the patient returns for a follow-up appointment. So this can be seen once they come for a follow-up appointments. Like you'll be after fitting, you have to tell them to come after 1 month, so that you will check how long the patient have used the hearing aid and how it is benefiting them, and whether it is to check how comfortness they are getting with the hearing aids. You will get to know how what changes you can make in future for them to feel better with the hearing aid, rather than going with uncomfortness, and they don't use the hearing aids later if they feel uncomfort. So you have to tell them to come after 1 month. So we have to alter the hearing aid for like how they're getting used to it and how they are using, whether they're using regularly or very intermittently, so that you can counsel them to use regularly. So then you can patient can get used to the sounds and get comfort with it. This provides valuable information to further customize the hearing aid fitting. So one of the feature in the hearing aid is it's one of the important component. It's a microphone which picks up the sounds from the outside. It's acoustic signal, and it sends to the it converts the sounds to the electric signal, and it sends to the amplifier. So because it changes energy from one form another, it is also known as a transducer. And microphone act in a linear fashion. So every time the pressure of the input signal doubles, for instance, the output voltage also doubles. Their relationship is known as sensitivity of the microphone. So uh, uh, it picks up the signal from the outside, it doubles, so the output voltage will also double automatically. And for a perfect microphone, the waveform of the electrical signal coming out of the microphone is identical to the waveform of the acoustic signal going into the microphone, basically. So this thing. So next is direction. Under microphone we'll be having directional microphone. So some microphones are designed so that it hear equally in all directions, that is called omnidirectional, and some are designed to be more sensitive in certain directions, like it focuses on front and it focuses to the right, left, wherever the speech sounds are coming. So nowadays the hearing aids are having this feature where it focuses on the speaker basically. So if speaker is sitting in front of you, it focuses on the speaker in front. If speaker is sitting next to you to the right side, it focuses on to the right. So basically where the speech sound is coming, so it focuses on to that, and it eliminates other background noises. um, uh, it's coming, so it enhances the sounds that need to hear basically. So there is dual microphone where the hearing aid will be having two microphones, and one microphone will be just for front sounds. So it picks up the signal from the front direction, and another microphone will be picking up the sounds from back and the side signals. So all these signals will be combined together, and it attenuates the sound, and attenuates the sound coming from different directions, and um, and rather than just the front. So there is multi microphone where the hearing aid will be having more than two mics. So it is called as multi mic, and many newer hearing aids and OLD transmitters have more than one microphone as input. So multi mics can provide some level of noise reduction, and they do this by using the phase differences to determine which direction a particular sound is coming from. So to enhance the sounds coming from in front of you, and to diminish the amplification of the sounds coming from the other side or back side of you. So it picks up the signal, uh, and it enhances the sound which you wanted. So next is amplifier. Basic function of amplifier is to make small electrical signal into a large electrical signal. Means it enhances the soft sound to loud sounds, and the amplifier can do three things. One is like they can make the voltage larger but not affect the current, and they can make the current larger and will not affect the voltage, and also they can make both the voltage and the current larger equally. So this is one of the component of the hearing aids receiver. It converts the amplified electrical signal into acoustic signal, and it works in accordance with the electromagnetic principle, that is a current flowing through a coil causes it to behave like a magnet. And there is a telecoil, which is also a feature of hearing aid. The user can select the coil instead of the microphone for amplification by switching the hearing aid to the T position. So many hearing instruments feature on automatic telecoil. So this is basically used to answer the phone calls clearly. And there is a volume control. Any hearing aid has a range of gain that it can generate, and the patient has some degree of control over this gain by using volume control or gain control. So patient only can adjust the volume controls. This already discussed, where the patient can alter his signals by himself. Hearing aids have a dial or a serrated wheel that serves as a volume control. Preset hearing aid programs. A variety of preset hearing aid programs accessed by pushing button by the user for different listening environments, each with different gain and the other settings. Next is adaptive gain control of the hearing aid. It based on the input signal spectrum, timing and the levels, it automatically controls the gain, allowing no user adjustment. um, And another feature is remote control. It adjusts the loudness of the signal. So these are the references where the information has been taken. And thank you for joining the webinar.